Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast, back with another article review. In this episode, I want to look at a really interesting recent paper attempting to replicate some of the very classic findings in motor control research. In particular, findings that are strongly in support of the idea of prospective control. So remember, in the ecological approach, right, we propose that actions are controlled prospectively, right? So imagine you are standing there in baseball or tennis, and a ball is hit to your side, say 30 centimeters from where you're standing, right? Or a foot or whatever measurement you want to use, right? In the traditional idea of predictive control, right? You predict where that ball is going, where it's going to pass you, how far away, and you use that to generate a motor program to get your glove or your racket to that location. Right? That's predictive control. The alternative one that's promoted in the ecological approach is prospective control. In prospective control, instead of predicting that future event, all we do is we couple or link our movement, so the movement of our glove or a racket or whatever, or when we're running, we link it to some information source that when we keep that relationship, we hold that relationship, it will result in us getting to to intercept at the right point, to our hand getting there at the right time. Right? We've shown this for fly balls. I've shown this in my second book. I talk about the bearing angle strategy. Right? This was one of the, and so what we're doing is we're controlling the current future, right? If we maintain this relationship between our movement and this perceptual information, then we will achieve the goal in the end. We don't know where we're going to intercept it or when, but if we just hold this relationship, we will, right? And this is the relationship. This was today. I'm going to talk about the specific case of ball catching. One of the very influential studies in this area. I'd recommend it. It's in, if I had to list the most important papers to read in terms of ecological approach, this would be on my list. Catching balls, how to get the hand to the right place at the right time. A large group of people, mostly right now, Bootsma. If I had a list of those influential, a lot of his papers would be on it. He's an incredible researcher in this area. But here you have a subject. There's a ball coming at them. They have to move their hand. They're only allowed to move their hand laterally to intercept the ball, right? You can intercept the ball as long as the current position of your hand and the current position of the ball, you close that at the uh, so such that you close that as the same speed as the time to collision, right? Which you can get from tau, right? So linking the movement of your hand to the visual information from tau will get you to the right place at the right time without ever having to predict it. Okay, so that's the basic idea. They ran a bunch of studies. There was two particular findings that seemed to provide strong support, right? It's evidence for this perspective control. So another key difference, right? In perspective control, we're continuously controlling our action. We're continuously adjusting our action based on the information from the environment. If that angle gets a little too big, we start moving our hand faster. If it gets a little too small, we move our hand slower. So we're doing continuous online control instead of ballistic predictive control. And they in these studies, they found two really strong pieces of evidence to support this. The first is commonly called the angle of approach effect, right? So imagine I'm sitting there, I have my glove in front of me, and the ball is going to pass 1 foot to my left, right? So the ball is passing if you're looking at this picture, my hand's at XB0, the ball is going to arrive at XB1, right? So I'm moving to the, what they did is they compared the movement kinematics, how quickly you initiated your hand, the glove movement, your speed, etc., for two situations. In both situations, the ball is going to reach past 1 foot beside you. In one case, it's approaching from the left. In another case, it's approaching from the right. So going across your body, right? And that's what it's trying to illustrate there. So both of these, the green one is coming from the left, the red one is coming from the right. They're both ending at the same point from you, same distance from you. They're just approaching from different angles. If you think about it, if you use predictive control, that shouldn't matter at all, right? In predictive control, you're predicting where the ball is going to be when it passes your body. You make a glove movement to get there. Why does it matter where it approached from? All that matters is where it's going to be, right? In perspective control, the approach angle affects the information source, the space, the distance between your hand and the ball. So that is going to matter. And in that study I showed you, the last one, the Pepper and Bootsma one, they found a consistent effect, a systematic effect of approach angle on the maximum velocity, right? So the kinematics of your intercepted, how you move your hand, depend on the angle the ball is approaching from, which is consistent with the idea that you're prospectively controlling your hand movement online, not making predictive control, right? So that was in their 1994 study. There was also another even stronger finding, I think, the idea of movement reversals. So the idea of a movement reversal is the special case. Imagine you're standing there with your glove in front of you and a ball is hit. And it just so happens the ball is going right at your glove right from the start, right? Right. So you happen to be in the perfect place to catch the ball without doing anything at all, right? So in this case, your glove, if you're looking at this picture, your glove is at XB1. The ball is approaching from different angles. It doesn't matter. It's coming to the same spot, right? What how should you move in this situation, right? In predictive control, you shouldn't do anything, right? You should predict from the ball flight that you're in the right place. You should just keep your glove there and do nothing. In perspective control, actually, where it starts, the difference between your hand position and the ball is, well, they predict that in this special situation, you should get to what's called a movement reversal. What that means is you should initially move your hand towards the angle the ball comes from, and then move it back to the same place you started, right? Even though you don't have to do anything, you should move your hand away from the interception point, then reverse it and move back, right? And that's exactly what they find, right? You move your hand in one direction and then move it back to the interception point, even though you don't have to, right? That's predict what you would expect based on using perspective control, because the online information is changing in that situation. Previous follow-up research, since this was a study by Gilles Montand from Marseille et al. In 1999, follow-up studies between these two effects, almost all of them have found the angle of approach effect. Movement reversals have been a bit more difficult, inconsistent, right? They occur in some cases, but not always. So they've been a bit more thing. And I cover movement reversals back in episode 349. I talked about what the importance of them, what they tell us about motor control, and I brought up this idea that they don't always occur all the time you would expect them to, right? And part of the reason why people thought this might be the case is that uh, quickly people catch on, right? The subjects catch on that in a lot of cases I don't need to do anything, so they get kind of expectations about what's going to happen. Okay. So in this study, this is a study I want to talk about today, was published in Frontiers of Psychology. It's a study by a group, and Frank Zoll, Nicholas Benigni, and Renaud Bootsma, all the people I've worked with before, great researchers. They're going to try to see if they can get these effects again, right? So this would, in terms of, I think this is good for a couple of reasons. One, these are very important findings, so understanding them more is important. But it's a replication. We don't get very many replications in motor control research. And anyone that knows statistics, right, the replication crisis, to finding that a lot of famous effects in psychology don't replicate. This is very, very important. This is classify this as a conceptual replication. What that means is they didn't exactly replicate the previous studies. They didn't exactly use the same number, same conditions, same participants, same everything. That's a strict repetition. What they did was to do some different variations on the same thing, but same basic idea. Okay. So in this study, so what they're going to do is they're going to look for the evidence of this angle approach effect and movement reverse effect in ball catching. They use the same basic paradigm where you're only allowed to move your hand laterally to intercept a ball approaching you. What they're going to do is create some uncertainty about hand position, in that they're going to give you a task where you have to move your hand around and then back to a point, right? In all the cases, most of the cases, you're going to come back to the same point. So your hand's going to actually start in the same position every time. But because you have to move your hand around, to create some uncertainty in the subjects, there's going to be more hand positions in terms of laterally. There's going to be more ball speeds. One of the things you'd predict in this is that when you have a faster ball speed, right, you have less time to catch it, right? So if a ball's passing me 1 foot in front of me, it's going to arrive in 1 second. I need to make a faster movement, right? You'd expect more movement reversals for faster speeds, because the visual information is going to be largest. This kind of thing that makes you go in the wrong direction. So they're going to use the faster speeds to encourage people to move right away when we expect these movement reversals to occur. And then there's only going to be on 14% of the time, there's a very small number of trials where your hand happens to be at the exact point where the ball is approaching. You don't have to do anything. So trying to prevent the subjects from catching on to this manipulation. Okay, so that's what they're doing in the study. The study was 10 students from Marseille, right? Pretty small N. That was something they talk about in the paper. So they're intercepting what they're doing is watching. They have a big tablet in front of them. They're watching objects move across it. They're sliding a stylus to intercept them, right? So not the most ecological, right? But they do, right? In the original studies, they swung balls on pendulums. So there's been lots of studies that have replicated these effects using more representative and ecological conditions more. But they wanted to have full control over everything in the study. So you're sliding the stylus along a rail to intercept the object. You have full vision of your hand and the ball the whole time, so it's not any kind of occlusion task. Okay. So there's a picture of it. The person's sitting. They're sliding a stylus along a rail, so they can only move it laterally. They're intercepting an object moving from a whole bunch of different trajectories and speeds. Okay, and the speeds are randomly chosen. Right, so that's the basic design. Okay. Um, the as I said, the subject had to move their hand around for a little bit to get back to the starting position. So it kind of varied. There were 7 different arrival positions ranging from 0, right where your hand is at the start, to 15 centimeters to the left, 15 centimeters to the right. Lots of different ball trajectories, different ball speeds, different flight times before you had to intercept. So they had quite a range of different conditions. Right? That's the point. Okay. The first thing, the results. What do they find results, right? So how often did people accurately intercept the object? On 80% of the trials, they were successful. The errors tended to occur more often at faster speeds and when you require further movements, not surprisingly, right? So kind of basic effects. But really what they want to look at in this study, the main thing of interest is the kinematics. How did you actually move? When did you start your hand movement? How fast did you move your hand? When did you reach the peak velocity of your hand movement? That's what they cared about most. So the first thing they looked at was situations when a hand movement was required. So when the ball was not headed directly towards the interception point, was not where your hand started, right? So you do have to move it. So what they found is people initiated early for faster effect speeds. They successfully replicated the angle of approach effect, right? So balls converging. So imagine a ball 30 centimeters to your left. When it was, I'll show you the plot in a second. When it was coming from the left, you got a completely different hand trajectory and a hand kinemax than when it was coming from the right, even though both are arriving in the same place. Okay. These were effects, these trajectory or angle approach effects were observed for every ball speed. Okay. There was kind of a special, when the ball crossed over the center of the screen, crossed over the person's midline, you got very big differences between when it stayed on one side of the body midline or one side of the screen. And here's the actual data, right? So here's the here's the hand starting at 0. The blue line, so they're going to move to intercept the ball, right? The hand is going to move to intercept the ball. The red, so what you can see is the red line and the blue line, if we pick 2 of them, right? They're going to the same spot, right? They're going to end up in the same spot, and you get completely different paths the hand moves to get to the same spot when it's coming from the left and when it's coming from the right? Perfectly predicted by the information, right? They're coupling their hand movement to the information instead of just predicting and going there, right? That's the angle of approach effect. So the fact that these red lines and blue lines are not the same is angle of approach effect. Okay. So that was the first thing to do. Then they looked at the special case, which was about 14% of trials when your hand was actually at the interception point when the ball was launched, right? So you did not need to do anything, right? What they found was when in about 26% of these cases, you saw a movement reversal. About 95%, the person moved the hand towards where the ball was. So if the ball was coming to the left, they would move their hand to the left, then back to the right to get back to the interception point. Okay. All participants exhibited these. Some people did a very few, some people did more. Okay. There was this effective speed. You made more movement reversals at higher speeds when you had to initiate it early. Um, they occurred at various times, right? So some of them occurred early, some of them occurred later. Right, here's a figure, right? So in this figure, the ball is coming. Your hand is at zero. You don't have to do anything. Right? All you have to do is keep the stylus there. You would intercept it. But people move their hand away and then back, right? They move their hand to the left and back to the right to intercept it, right? That's what a movement reversal is, right? So again, it's pretty convincing evidence, I think, in support of prospective control. So the bottom line of the study, I think it's very, very well done. They replicated both of these effects, the angle approach and movement reversals. So suggesting that we're not predicting where the ball is going and then moving our hand there, right? We're continuously controlling our hand movement based on online information, which makes us move our hand differently when the ball is approaching from the left and when it's approaching from the right, even when they're going to end up in the same spot. And it causes us to do these movement reversals. In the special case where our hand is in the perfect place to intercept the ball right from the start, we move our hand away from that point and then back, right? Um, what was interesting, again, similar to what I talked about in that previous episode, what seems to happen is the movement reversals are not occurring in every time you would predict them. What the authors take is, and they kind of discuss this in detail if you're interested in it, is they're not using a simple control strategy, the control strategy based on the initial position of the ball. There's also, it seems to be more complicated. Um, the um, the information it seems to be based on if you go, it's this special kind of information called fractional information, right? And this is an example of what we talk about a lot in ecological approach, right? The information is higher order. It's not very simple information. I talked about this back in episode 25C, so going way back. So it's based on a combination of the current ball position and on the future ball position without predicting it, right? And you can look at that episode to show you. So indeed, they did replicate the studies. What they're showing, though, is that maybe the information that we thought we were using in terms of what we were coupling to is more complex than we thought, right? But overall, I think a very good study. I think it's important that we continue to show these findings, replicate these findings. I think it's very, very well done. If you want to understand, I know I didn't go into a lot of detail, but if you want to understand the information, this higher order information, have a look at that episode and the paper link there. It goes into a great deal on that. Okay. So that's it for today's episode. Thanks for joining me. Cheers for now and keep them coupled.